This is the demo I normally do in class, and it says if I mix the reactants together, it stays pink, but the product, Mn2 plus, is colorless. Let's explain that by balancing these equations. I'll make 1/2 reaction of NO2 minus going to form NO3 minus. We have the same number of nitrogens, so what we have to do is add a single water. So now we have balanced our oxygens. The problem is now we're short on hydrogens. So what we will do is we will add 2 H pluses to the product side. At this point, we have all of the elements balanced, and what we need to do is balance the charge. There's a -1 on the left, and there is a -1 and a +2 on the right, so there is a +2. That says we have to take and add 2 electrons to the product side so that we can have a charge balance. And this looks like it is going to be the oxidation portion of this reaction. Now let's walk over to the other side. MnO4 minus goes to form Mn2 plus. The MNs are fine. What I need to do is balance the waters. So what I will do is MnO4 minus makes Mn2 plus and 4 H2Os. So by adding 4 waters, I now have 4 oxygens. But doing that, I've created hydrogens. So I will have to have MnO4 minus plus 8H plus goes to form Mn2 plus and 4H2O. At this point, all of my elements are balanced. I have a +8 and a -1 for a +7 as the reactants, and I have a +2 as the products. That means I have to add 5 electrons to the reactant side in order to bring the charge down to a +2. And on the product side, I have Mn2 plus and 4H2O. So the reason for doing this example, this is the reduction. For our oxidation, we have 2 electrons. For our reduction, we have 5 electrons. What we have to do is have the same number of electrons, which is 10. So we'll multiply our oxidation by 5. We'll multiply our reduction by 2. Not enough space, so a brand new piece. We will have NO2 minus plus water makes NO3 minus plus 2H plus 2 electrons times 5. Then we will have the 5 electrons plus MnO4 minus plus 8H plus going to form Mn2 plus 4 waters, and we will have to multiply that reaction by 2. When I add them together, I come up with 5 NO2 minuses plus 5 H2Os plus 2 MnO4 minuses plus 16 H pluses. That's going to be my reactants, and I have 5 NO3 minuses plus 10 H pluses plus 2 Mn2 pluses plus 8 H2Os. So that's adding. We have all of our electrons balanced. What we need to do now is get rid of the things that appear on both sides. On both sides, we have water, and we also have H pluses. We will get rid of all 5 waters as the reactant and come with 3 waters as the product. Get rid of all 10 H pluses as the product and come up with 6 H pluses as the reactants. Now I will rewrite. 5 NO2 minuses plus 2 MnO4 minuses plus 6 H pluses make 5 NO3 minuses plus 2 Mn2 pluses plus 3 H2O. Nobody is going to type those equations on your exam. What they may ask is, what is the sum of the coefficients of the reactants? That would be 5 plus 2 plus 6, which would be 13. They may say, what is the sum of the reactants, of the products, the coefficients? And that would be 5 plus 2 plus 3, which would be 10. So that's how they're going to ask you things on the midterm exam. I've had to record this 4 times already because of the time, so I'm going to move on to the next example. The next example is balancing a reaction in basic solution. What you need to do first is balance it in acid solution. So I'm just going to hop right in. I have MnO4 minus going to form MnO2. Deficient of oxygens on the product side, so I'm going to add 2 waters so I can have 2 waters present. Now I'm deficient of hydrogens on the reactant side, so I will have 4 H pluses plus MnO4 minus going to form MnO2 plus 2 H2O. There are not any charges on the product side, so I'll end up adding 3 electrons to those 4 H pluses and the MnO4 minuses, giving us the MnO2 plus the 2 H2O. This looks to me like a reduction. So what we're hoping for on the other side is to have an oxidation. I have Br minus going to form Br2. I need to put a 2 in front of the Br minus in order to balance it. And then to balance the charge on both sides, it'll be Br2 plus 2 electrons. So here I have the oxidation. Looking at this problem, I have 3 electrons in my reduction. I have 2 electrons in my oxidation, and my common multiple would be the number 6. So what I will do is I will multiply the reduction reaction by 2, and I will multiply the oxidation reaction by 3. Putting everything together, I have 2MnO4 minus plus 6 Br minuses plus 8 H pluses going to form 2MnO2 plus 3Br2 plus 4H2O, and now I have it balanced in acid solution. But the problem said we need to balance it in basic solution. So what you want to do is add enough OH minus to each side that you neutralize the H plus. So I'll add 8 OH minuses. This will give me 8 waters. I've neutralized the acid. By adding those 8 OH minuses to the reactant side, I also have to add it to the product side. Ran out of space, so I'm going to move on to a fresh slide, and what we will do is look at the equation. So what we now have is 2 MnO4 minuses plus 6 Br minuses plus the 8 H2Os. It's going to go to the other side to form 2 MnO2s plus 3 Br2s plus 4 H2Os plus 8 OH minuses. Just like in the other problem, we have to cancel out the excess water. It appears here on the reactants, here on the products. All the water is going to go away and we'll have 4 waters left over. The end result is 2 MnO4 minuses, 6 Br minuses, 4 H2Os, going to form 2 MnO2s plus 3 Br2s plus 8 OH minuses. There was a test question on midterm 3, and it said, what is the coefficient of the OH minus and which side does it lie on? So for this problem, we would say 8 is the coefficient and the side is the right. Can't guess these, so practice them. Again, going quickly because there's a limit on the YouTube video side. This is an example of disproportionation. We had one with nitrogen when we were doing charge. Now we are going to have one with bromine. I'm going to write it a little bit different. I'm going to say bromine plus 2 electrons makes 2 Br minuses. Hopefully you've got that one down pat. The other one, I'm going to say 6 H2Os plus Br2 goes to form 2 Bro3 minuses and 12 H pluses plus 10 electrons. Looking at this problem, I have 2 electrons here, I have 10 electrons here. It means I have to multiply the bromine equation by a factor of 5. And I want to go through this because there's a couple little twists as you go through this one. We would add these together and we would come up with 5 Br2s plus 6 waters plus Br2, making 10 Br minuses plus 2 Bro3 minuses plus 12 H pluses. What I want to point out that with the disproportionation, you often have to combine terms. And it's probably easier to write it out because that way you're not going to make a mistake. Instead of like just thinking in your head, I'm going to make a change here or a change there. So in this case, the problem still is not over. Notice how the numbers can all be divided by 2. And so when we divide by 2, what we come up with is 3 Br2 plus 3 H2O makes 5 Br minuses, a Bro3 minus, and a 6H plus. So again, no one is going to type these equations out. And you'd have totally different answers. If they said, what is the sum of the coefficients of the reactants? The answer is not 12, the answer is a 6. So please do the homeworks. You need to just to practice so that you can easily make it through this kind of problem. Again, sorry for talking quickly, but I've recorded this so many times, I have to be under 15 minutes.